Okay. Um, Good evening, people. My name is Andrei. I'm working in University of Brasilia right now, but I'm finishing my PhD in Technological University Dublin. My supervisors are Brian Keegan and Susan Mckeever. So we are interested in collect the information about software vulnerabilities that are released in social media and hacker forum. So this is a part of ongoing work, which is we are trying to understand the robustness of classification models applied to this area to detection of software vulnerability on social media. So that's our main goal, is to detect if there is concept drift on these models, in how long they will be useful without training, or what the best practice we should take when we deploy classification modules for that applied area. So I'm gonna go to the forward slide here. Let's see. Yeah. Oh, I'm gonna explain the motivation for our work is as I said before. So we are interested in software vulnerabilities, those vulnerabilities that are not built in software on purpose, but they can cause a lot of damage if you don't, if somebody knows before people patch their software. So we have some examples of these vulnerabilities. So I would like to remember, if you are not familiar with them. So we have the case of Equifax, which was a vulnerability on Apache structs that was one patch that by the company Equifax that allowed the hacker to attack this company and extract a lot of information, credit information from the users. The thing here was the problem here was they didn't patch the Apache struts, which allowed attackers to break into those systems. So, but we have some other vulnerabilities like the Facebook View S that was introduced in 2017 and was discovered a year later. So we don't know if people discovered this before and was using these for malicious acts. Actually, was found that the millions of tokens were published through these vulnerabilities. So people found these vulnerabilities before it was public disclosure. And we have another one which is very famous. It's called Hot Bleed. It was a vulnerability in OpenSSL that was introduced in 2011 and was discovered after 3 years. So we remain with this vulnerability in our software for a long period of time. And these vulnerabilities, some of them were discussed in dark web forums and hacker forums, and people were selling exploits for them, making exploits, proof of concept, and that's the kind of communication we are interested in. So let's go to the next slide. So as I said, our aim is detect the concept drift on machine learning classification models applied to detect the software vulnerability communication on social media and in social network and hacker forum. So in this particular work, we are interested in concept drift that's indicated by the performance of these models over time. So we put the model and we evaluate through time and see how the performance what will happen, if you keep flat or if it will decrease. So this is based, I would say that what we've seen in research today is that they take a static word view, which is we train the model and we test the model and then we deploy the model and we are done. So there are a few works, there are a lack of study on this area for the software vulnerabilities communication that discuss these, the application of these models over time. And as the language is very dynamic, at least for hacker words, terminology, jargons that describe vulnerabilities and techniques. So we believe, and we have shown that these affect the performance of the model over time. So we are going to follow these two research questions, which is the first is, does the accuracy of machine learning models created to detect software vulnerability communication in social media posts degrade over time? That's our first research question. The second is, can we alleviate this problem using typical concept-driven solution method? Let's go. Yeah, the experiments start with 3 data sets, 2 from hacker forums from deep web, which is we need to have a user account to have access to these data sets, and 1 for Twitter, which was profilers from InfoSec user that I used to discuss these kind of things and to disclose vulnerabilities. In Twitter also is uses for the coordinate disclosure, which is a researcher that found a vulnerability. They get in contact with the vendor and they schedule a time for the vendor to release the patch. If they didn't release the patch for that vulnerability, they disclose on Twitter or inform people that that software is vulnerable. And then we are going to use binary classification models. In the difference here in this evaluation is that the models are trained according to the timestamp. The training is, we are training in a period of time and testing in a other period of time further. So we took 2 types of evaluations. We call it the static and dynamic evaluations. And we have the experimental design is this one here. So for the static evaluation, we use the messages for testing, further messages from the training for testing and get the results. The difference for the dynamic evaluation is that we take this message that was tested and we update the model with this message. So we are recurring updating the model during the time. Yes, these messages are organized in sequence according to the timestamp. Yeah, that's it. And we are going to give these results in average class accuracy. So yeah, this is the details of the dataset. We are using the Cracking Arena forum, Garage for Hacker forum, and InfoSec profilers from Twitter. They have more or less the same quantity of messages. The time span of these data sets are different. So we have 1 year for the D2, which is the Twitter source, almost 7 years for the Garage for Hackers, and 5 years for the Cracking Arena. And yeah, but we took 1 year for each in order to evaluate fairly. We understand that we need to evaluate in the same period of time with the same amount of time. And we did a binary classification where the positive example would be like somebody saying POC, which stands for proof of concept, for dirty call, which is a vulnerability they found, if I remember, is the CMS program, as I think it's Joomla, and they put the URL for this POC. And the negative example would be something which is not vulnerability communication, would be like, it's amazing, a hacker can put up with a sociologist. There's no malicious thing in this message, despite of having the word hacker we found that there are a lot of keywords that can be in both examples, positive and negative. This is an example of negative that has keyword hacker, but it's not malicious communication. Next slide. This is the range of messages, the volume per date. So the D2, which is the Twitter source, we have this spike here, the 1 year, this orange spike, and we got these spikes from the others data sets, like the blue one, the spike one, and in the green we got the majority, the part that has more messages for using these for doing this evaluation. Of course, we started with something. We need to create model. So we create this model based on the which we call the start model. This is the base for these two evaluations. The algorithms used was support vector machine and bag of words feature representation. It's a simple one. So the default parameters were as from the scikit-learn. We didn't tune it because we use 3 different data sets. We want to keep same hyperparameters on those to evaluate them. As I said before, the evaluation metric is the average class accuracy, which is well suited for imbalanced data sets, which is our problem here. We have way many negative instance than positive instance in these data sets. Yeah, and we trained it with the first month of the year. We did a fold cross-validation for taking these the performance of these models, and we used also a random oversampling of the positive instance to increase the accuracy as done in our previous work. So this is the start model that starts our evaluation. And for the static and dynamic evaluation, the static evaluation, there is no retraining, which means that we create the start model with the first month, and we tested in every 2 months instance until 1 year. So, and we didn't retrain them. On the other hand, the dynamic evaluation, we retrained them, we tested, and then we trained with this incoming instance. So we have the proportion of the distribution of this instance of these in each data set. We see that we have low positive instance in our phases of our tests. So in window W1, we have 10, hopefully 12% of positive instance on those. And that's it. We create the starting model and we tested 4 times in 4 windows, sequential windows. And once again, our goal here is to measure the performance of these models over time to see how robust they are and how the performance will keep during the time. We are considering the fast change of the jargons used to describe software vulnerability communication. We assume that all models will lose their performance over time. That's our first assumption, that they won't stand the same accuracy over time. And the other assumption we have is, considering a model with a performance decreasing over time, we assume that these issues can be avoided by retraining periodically. So let's go. Okay, let's answer the first research question here. We use the static evaluation to answer this question. We see that In D1 and D4, which are both hacker forums, we see that we have a decrease in performance, so over time. W0 is our start model, and the following are the evaluation instance. We see a pattern here in hacker forum that the accuracy of the model don't keep the same as in the beginning. However, we see that for Twitter, the accuracy stay almost flat with a little bit of increasing in these Twitter dataset. So we assume that we have a concept drift in hacker forums. Let's go to the next slide. And for answer the second question, we used the dynamic evaluation. First, we just retrained with after the testing, we retrained with the incoming instance. We use this blue bold line here is the previous static model. We put this as baseline, which means that this blue line is we didn't retrain the model over time. However, how you can see here, in practically virtually all other models that was retrained, we improved over the non-retrained model. So yeah, it shows that retraining is a good practice to do with your model applied to this area. And we see that we have the optimal trade-off is 50% proportion of retraining. So we can retrain these with 50%, that we will have a similar result with 100% retraining. If we retrain everything, we will have a trade-off. We can reduce the amount of labeling that's needed, and we can have at least as good as retraining every incoming instance. This model here is okay. On top of the previous results, we decided to weight the instance. So with the retraining of 50% that we found that was a good good mark to follow. So retraining the 50% of the incoming instance, we put some weights on this new instance. So we worked with a range of weights, a double, triple, and 5 and 10 on the newest instance. The baseline here changed. The baseline here is not the static model anymore. The baseline is the retrained model with 50% of new incoming instance. We found that the optimal trade-off value is if you put a weight of 3 on this new instance, we have an improvement over the baseline model. And we see that retraining in putting weights in the same time is better than only retraining the model. Okay, so to better calculate these trends, we calculate the slope of the line. We put these in a graph and put the regression line to fit those points. And we calculate the slope of these lines. This is for calculating the steepness of the line and give us the trend of the line of the performance of the model over time. So the negative values are in the decreasing tendency. If you see a negative value, you will see that you can understand as the performance will decrease. For positive values, the performance is increasing, or 0, it's flat. We see that for the static model here, we have we have almost all models are negative, which means that over time, if the model is static, if there is no training, if these models are applied to detection of software vulnerability communication, they won't last much. So it's a bad thing to just train in the model and put and deploy this model. So you need to take more actions to bring this model to more robust over time, I would say. Yeah, and we see also that the dynamic model, just by doing the retraining, we can avoid the tendency of decreased performance only by retraining these dynamic with only by training these models with the incoming instance. And we see that by the dynamic model retraining and putting weights on the newest instance is the way that better performs the model over time. Okay, let's go to the final. To summarize everything, what we did here was we have addressed the concept drift on supervised classification models applied to detection of hacker communication within a period of 1 year. So we identified that concept drift affects the performance of models applied to hacker forums, which were the D1 and D4 datasets. We believe that these hacker forums have more dynamic content. They have more information, technical information that drive these performance down with the models. So we also identified that the concept does not affect the Twitter dataset, as opposed to the hacker forum. Twitter is made for broad audience. There is not many words, technical words there. I think there is a more direct conversation. That's why models applied to Twitter dataset might not suffer as hacker forums from the same problem. Also, we identified that retraining periodically is simple and efficient alternative to make the model more robust over time. Yeah, we found the optimal values of 50% proportion for training and more weights, input weights on the newest instance, that they are more important for the performance of the model. I think as that's what the results said to us, that the new instance are important. So if you put some weights on this new instance, the performance of the model will be better. And as a just a caveat here, we know that 50% proportion is difficult to measure when you are receiving this instance. You don't know how you don't know the size of the incoming instance. So 50% proportion might sound silly because we can measure this. But what this said is we don't need to relabel every incoming instance. You know, you can use a proportion of those instances to improve the performance of your model. And as a future work, we want to study the algorithm for detecting this drift without using that fixed window. So we have some example of algorithms that work with the samples, and then you can do it as string-based. You don't need to fix those windows; they are more dynamic. And then, as I said before, as maybe not feasible to relabel 50% of the incoming instance, we want to investigate methods to access the worst to label messages before relabeling, because we know that not all messages would be necessary to give the best accuracy for us. And that's it. That's the end. Thank you, everybody.
Thank you very much, Andrei. We have few questions for you.
Okay.
Some people are wondering in slide 13 how you decide the weights.
So we started with the 2+2. We put the double of the weights, and we decided to increase at certain point.
Mm-hmm.
And then we just decided by increasing the weights and see if there in this range I would have the best performance. If in +10 I would have best performance, I would continue to increase the weights.
Mm-hmm.
So
Okay.
that was more to understand if these new instances are more important than the oldest one. So that's.
Mm-hmm. So have you been able to identify what causes the concept drift? Is it because there are new vulnerabilities, or because hackers, they use different expressions?
Yeah, that's a very good question. So we did a briefly overview on these messages in the we see that the trends of the attacks change over time. Before we have experienced the ransomware, and so people are discussing a lot of ransomware and how to put the ransomware to work in the machine, how vulnerabilities they allow the ransomware to take action. So it's a trend topic. So I think these changes, and that's what affect the performance.
Okay, assuming that you need to train 50% of the data, which it seems quite a lot if you are getting data from forums. But assuming, having that assumption, how long does the model last after you need to retrain again for the concept drift?
So, sorry, I didn't get the final.
So after labeling that 50% of the data, how long you can use the model and still get the same results without needing to retrain the model?
So as we see in the first slide, for hacker forums, we don't stay with the same results. If we train it, if I test it again 2 months after, I will see a decrease of this accuracy. So for hacker forums, it goes down. So for Twitter, it stays the same or improve it a little bit, but it stays the same during the year.
Okay. Have you considered any human skills, competencies, or knowledge data as inputs to requires as a required supervision for the classification?
Yes, definitely. We needed to use human input for the labeling, because this is expert knowledge. So we need to use people that know about what is vulnerability communication. And we will need to use these people to relabel to maintain the performance of the model. So that's why we need to, as a future work, we need to investigate how to use just a sample of the worst to label messages. So we need to find what these messages are for the accuracy of the model.
Okay. So with that, we use all the time we have. Thank you very much, Andrei, for your presentation. It's been great.